Anyways, right, I am extremely excited to introduce to you today hotshiny. It's a thing that I wish we have had already like 10 years ago. But hopefully you will be as excited as me by the end of this one. So I'm Jesus Rodriguez Perez, Principal Data Scientist at Dark Peak Analytics. And this is my talk on hotshiny. So R-HTA is absolutely great. And it allows us to build very good looking applications very, very quickly. And it enables complex applications like Care Closer to Me, Talk to Home, sorry, introduced by Oliver earlier this week. It's shown over there on the right. Amazing application with geo functionalities and that kind of stuff. It is R-HTA is an R package, so obviously allows us to build and integrate our analysis directly into the app, into our web application, so that it can be then deployed many times just with one click directly to the POSIT infrastructure. So it can be very easily shared with colleagues and customers, which is absolutely amazing. And I absolutely adore Shiny. Contrary to what lots of people in the room think of me, coming from the computing science side of things and having been developed with other kind of tools. But, big but coming. There is one aspect of Shiny that really has been very, very painful to me, and is doing modifications on applications. And the more complex the application becomes, the more painful it becomes. So we have all been there. Lots of people have been developing with Shiny applications. Every time you save, you have to switch several tabs, upload a CSV, and maybe modify a bunch of inputs just to be able to see that specific change that you are looking at in some sub-page somewhere. Just to showcase that very quickly, I'm just going to show you one video of the example that I'm going to be also introducing later. Let me just put this one in full screen. I hope you can see this. So just a quick explanation. On the left-hand side, obviously, we have the IDE with all the Shiny code. And on the right-hand side, we have just a relatively complex application that you are going to be familiar with a side panel with inputs and a right panel with plots and results and whatever. So this is now running normally. Also, this is the normal experience with Shiny. And what I'm going to be doing in this example is just adding one little notification under the second tab, Power and Torque, that is just going to notify and say if you are specifying a displacement here higher than 10 liters, it's just going to say, is this really a car? So obviously 10 liters is way too much for a car, I would say. So we are just adding first the usual component on the UI side of things, where we're going to be displaying the notice just right under the input for the displacement. And now we're going to go, since it is a dynamic or a conditional output that we're going to be thrown in there, we go into the server side of Shiny code, and we are just going to create a little piece of code very similar to the one above, literally a copy actually. But it's just a conditional saying if the displacement is higher than 10, so higher than 10 liters, you're gonna say something, a little notice is gonna appear saying, is it really, really, really a car? So I'm just doing some corrections there as I copied the code, higher than 10, as I was saying, and just gonna change that text. Just gonna jump in a bit. Are you sure this is a car? So we save. Everything's nice. We go to the tab. We have to navigate to the tab, and now we have to reset the liters to satisfy the condition that we have set there. No? So over 10, we are happy. The notification appears. But what if we need to do a little modification, like changing the color, for example, just one it red, so it can really stand up. I saved, and it went back to fuel consumption, and now I had to actually press again power and torque. And now you realize here as well that displacement has been reset back to 2. So I need to go a value over 10 to be able to see the new notification that we have built. And obviously, if we keep doing modifications, like changing the font weights, like in this case, we are going to have exactly the same situation. Saving brings that back to fuel consumption, move back there, and then you have to retype or change the inputs again to show the changes that you are trying to achieve them. So that, to me, is one of the biggest, if not the biggest, limitation that I have with Shiny, because it can really hinder, first of all, your flow, your mental process, and really slow you down as you are developing more complex applications. So what is the problem with Shiny? And is that it cannot determine the code that have changed, so you cannot do anything about it, unlike more modern approaches or more commercial approaches. So to edit any code, you have to restart the whole application, which will destroy the in-memory or current state of the application. So for observers and reactive, so these are part of the Shiny language, are opaque closures. So you cannot really do anything with them. So they cannot be inspected, they cannot be compared, they cannot be patched, you cannot do anything about it. They exist, they're used, and then they're destroyed once you finish. So the concept of the reactive grab only exists implicitly at runtime as you are running the application. If you didn't understand anything of what you said there, don't you worry. the message is that the only option to really show your changes is to restart the application and rebuild from scratch. So it takes longer to develop applications. So the solution is hotshiny. So what I've built here is a Shiny compatible replacement with true hot reload. And for that, the changes are going to be detected and applied while the application is running. And unsurprisingly, the state is preserved, as we saw before with the example. So inputs that you have changed and things that you have been doing in your session will be preserved, and then the changes would be as a response to the changes that you have already done to the application or the current session. It implements most of the Shiny vocabulary, so most applications would run without modification, although obviously this is an alpha level application, so it needs to be tested a bit further, but yes, it should. So the developers can just use the programming style that they've been familiar with up until now using Shiny. The only difference is that we have a very different underlying technology that is going to be driving the execution of the program. So instead of restarting the application with every edit, the hotshiny will just apply a very targeted update to the running application and only replace those elements that are connected to the affected tool. So you show you a quick demo of hotshiny. Hopefully you can see this one. Stop it. Stop because it's very quick. It's so fast I need to stop it. So on the sides, we have the same application as before. And I'm just going to do a modification to what we already built before, just so you can see the difference in the experience that we get developing applications. So I move to power and torque. I'm going to add or change the input here for displacement, and it's going to put the value above 12. And we are exactly where we were there before. So now I'm just going to go and make a little change in the text, save, and you can see the text appearing just very quickly and automatically there without reloading. We change the color to purple very quickly. We are not going to change the font weight. We are going to just add a little margin because it's very close to the bottom here. So just add 20 pixels just to separate that very quickly. And as you have realized there, we have not changed anything. The inputs are preserved. And yes, this just creates a much more pleasant and fast development experience. And I think, oh yeah, and I just changed the text here just for fun. No reloads and a little happy face there. This is the kind of experience that I really, really like when developing applications. So the core idea here is that all the functions or the language that we are used to from Shiny, it retains all the names and all the signatures. So all the parameters that go into each of those functions are exactly the same. But instead of executing it straight away when you're running through the code, it just registers an intent. So the idea of kind of trying to describe your code as in a kind of virtual way, creating a tree representation of your code and of all your dependencies and in the reactive scripts and whatever you have in there, is created as a tree representing your code, which is something that we call also a virtual DOM in modern development. So one core concept here is that the reactive nodes and all your code effectively becomes data. And the data, as we know, it can be compared. So we can compare what's has changed within the current version against the modifications that you're doing in the code. It can be versioned and it can be replaced. So you can modify and compare at will. Well, obviously this is happening directly and automatically by hotshiny. It's being managed by that. So this is a relatively old trick already. This has been done in many commercial technologies like React or Vue. So this is just say 10 years plus old. And so what's happening, just a quick description, is that whenever something happens, a file watch is just detecting the changes of the files in your file structure, and those files get reparsed, and then a new kind of tree structure that is going to be compared to your old tree structure that describes your code is built. So this is when the comparison happens, and it's just flagging which nodes are supposed to be left unchanged. Some are modified, some have been added, some have been deleted. So that's happening in real time when we save. And then hotshiny also snapshots the values. So it stores the values from all your inputs and your state from all the unchanged nodes. And then it's going to restore them the second the new tree gets instated into the current state of your application. And all those values get refreshed and re-added into your application. So effectively, only the nodes that are invalidated only modified nodes, are invalidated or executed. So only those nodes that are affected by a change in code will be cut off and reconstructed, re-executed in the tree. So the client side of your application only receives a patch, a small change. There's no browser refreshes, no blinking, no loss of states. Just a quick comparison here of hotshiny versus shiny. So reactive and observed functionalities and reactive and observed functions are executed immediately, whereas in hotshiny, this just registered in a conceptual graph structure that describes your code. Reactive logic is expressed or captured as closures, which we can think of them as functions are listening to variables. Whenever the variable changes, the code inside the function gets executed, as I was saying before. In hotshiny, this is just recorded as a description in the tree, if you like, in nodes in the tree. The reactive graph that describes your application is implicit. You cannot do much with it. You can sometimes observe it, but you cannot do much with it. In hotshiny, it would be something explicit. It can be versioned and compared and modified. Same. So R-HTA will force you to restart. So you lose the state. Hotshiny, you can compare the graph and preserve the state and just modify what needs to be modified. And obviously replace the whole, in R-HTA, it will replace the whole HTML versus hotshiny, where you just do small incremental changes as you modify the application. Obviously, we cannot support everything, but most of the standard language is supported or should be supported. I will also be placing some nice messages for maybe unsupported functionality that we know. But yeah, you can expect stuff like non-deterministic side effects to not quite work because of the way the application is meant to be running. So if something is changing, for example, with time, something's modified with time, it will be restarted at a different time and it will show a different result. So dependencies and something like that. If you make a change, it will show something different. And so there's a few bits and bobs that you cannot really replicate with hotshiny, but we would provide some gates there to fail safely, at least. In summary, you get a faster and more efficient programming experience. Hotshiny keeps the Shiny API unmodified, not practically modified, but completely unmodified. So you don't need to learn anything new, just can work as usual. But the only idea here is that the code itself becomes data, not cursors, data in a tree, which this is the key change that unlocks the capability of hot reloading and other functionality that's also included, but I'm not going to mention today. The cost, just a few small uncommon patterns that are unsupported, as I just described. And it is exactly the same path that other technology has followed, 10 years ago, or over 10 years ago. hotshiny is publicly available, so if you guys want to play with it and start doing your next projects with it, please do. So you can also give me some feedback, and I can also learn from it and make this just a much better tool for everybody. I cannot do this alone. So yeah, please feel free to get in touch with any questions. So if you want to contribute, obviously the repository is public, so you can just report anything directly there in the repository, and we can do PRs and the usual stuff. Thank you for listening, and yes, I hope you liked it, and any questions and discussions are there.
Thank you very much, Jesus. I know that it's a hot day for hotshiny, so yeah, a very relevant topic, and I'm sure anyone who's had the pleasure of having to make lots of small sequential changes to a Shiny app would appreciate their time back. So yeah, fantastic. There was one question in the chat from Yishang who says, I have trouble making my Shiny app comply with current web accessibility rules, such as screen reader. How to check whether the produced Shiny app compatible with accessibility standards. I'm not sure if that's directly relevant for this, but I don't know whether that's something you can talk to.
Yeah, that is a tricky part of web development. Definitely doesn't have to do at the moment with hotshiny. So hotshiny is technology just to make us work faster, no? Yeah, the only recommendation I can really tell you is I think there are websites where you can assess your application against certain rules for accessibility, and it can automatically flag in your application what's wrong and what's not, or what could be improved. So probably just look for something like that to guide you in the process.
That's great. And we had a question earlier, which is kind of about Shiny more broadly, which was about where it's relevant to start shifting away from Shiny. And I think I had a back and forth. We had a back and forth on the chat earlier, where I was saying Shiny is great for prototyping and to get to a certain stage. And I wondered what your thoughts were on where the relevant places to start to shift away from Shiny to other tools and what the strengths and benefits are.
Yeah, I think unfortunately many times this decision is driven by what the customer expects to receive, or what they are more familiar with, or maybe just what their platform or supports. In my opinion, what I would be most comfortable with is the second we start having a multi-page application, not just one page where you show maybe a few tabs. But the second you start having multiple pages, I would already run away from Shiny and start developing with something else. Obviously, I'm comfortable with it, and I understand that not everybody has that. That they don't have the experience developing with other tools, so it's a bit of a harder task for other people. But with the Gen AI, it makes it so much easier as well. This is a couple of prompts, and you have an application running with modern software.
Fantastic.